Okay, so we're going to approximate zeros of a polynomial function. I could actually throw in the word real zeros because specifically we're dealing with just the real zeros of a polynomial function. And then we're going to do a problem from page 497 of your book. This is number 5. The function that they give us says f of x equals x cubed minus x squared plus 1. Now, the thing about this function is the real zeros are not integers. They're decimals. Alright? If I were to graph this thing, if I were to do the graph of this, and I don't know where the zeros are, don't get me wrong, but if I were to graph this thing, the graph might do something like this. Okay? This is a cubic function. Okay? It's got 3 zeros, but notice that none of the zeros cross at the intersection of grid lines. None of the zeros are integers. They're decimals. So what we're going to learn how to do is to approximate the real zeros to the nearest tenth. And we're going to learn to do it by using a table, and then we're going to learn to do it by using the calculator and graphing it on the calculator, and it's going to tell us exactly what we need. Okay? So we're going to do it basically 2 ways, using a table and then using a calculator exclusively. Okay, now what we're going to do is we're going to choose some possible x values. We're going to put them in a chart. Okay? Now, what would be some logical x values to choose, do you think? Now, I probably need some negatives and some positives. So, give me some logical ones to choose. We don't want to choose a bazillion of them. What? Negative 2. Negative 1. 0, 1, and 2. Let's try those. We might need to go with a few more. We might need to use negative 3 all the way to 3. I don't know. I don't know. So we're just going to test these. All right? Now, how do we test them? We take our calculator and we plug them in. And we just get the values for each one of these x values.
Just plug them into the problem?
Plug them into the problem. Okay, so in other words, you're just make sure you use parentheses, but you do a negative 2 cubed and so forth. I'm going to pause the video and let you do that, and then we'll come back through. Okay, so what was the f of x value when x is negative 2?
Negative 11.
Negative 11. All right, what was f of negative 1?
Negative 1.
What was f of 0?
1.
What was f of 1?
1.
What was f of 2?
5.
Okay, now, if we were to choose other negatives and other positives, what you would see is that the farther to the left I go, the bigger my negatives are. The farther to the right I go, the bigger my positives are. Now, what we're looking for to determine the approximate zeros, we're looking for changes of sign in our f of x values, which are basically our y values. So where do my signs change? Between which 2 x values do they change? Right here. I'm going to draw some double arrows here. You'll see the same type of example in your book. So where does it change? It changes when between, what we know is that we're going to have a 0 between 0 and 1. Now, that saying 0 between 0, that kind of doesn't make sense. But a 0, we're talking about a 0 of the function. We're going to have a 0 of the function between these 2 x values. Now, how do you determine what it would be to the nearest tenth? You're just going to take the average. Okay? Just basically take the average. What's the average of 0 and 1? 0.5. So we're going to say that 0.5 is the approximate 0 of this particular graph. Now, are there any other zeros in here? Nope. So what does this probably have a multiplicity of? Probably a multiplicity of 3, because there's no other zeros, right? So I could have written this graph so that it looked something like that. Okay, instead of having 1, 1, 1, we could have just had 3. That's what it appears it's going to be. Now, what allows us, there's a rule that allows us to simply basically take the average of these x values in order to get our approximate root. And this is the rule that does it. If you look at page 494 in your book, there is a rule that is called the location principle. It says this: suppose y equals f of x represents a polynomial function, and a and b are two numbers such that f of a is less than 0 and f of b is greater than 0. In other words, one's positive and one's negative. Then the function has at least one real 0 between a and b. So that's what this is saying. I've got a change of sign here. One's negative, one's positive. They're consecutive. Therefore, there's a 0 between 0 and 1. Now, this is as good of approximation as we can get. Because, you know why? Because we don't have any decimal values or anything here. If you look at the top of page 494, you'll see it says make a table of values. You see 3 different tables of values. Okay? The first one has values from a negative 11 to negative 4. And then it goes all the way down to positive 12. These are basically the same table, just broken into 3 parts. Look at the changes. It says in the first section here, and I can go to the camera for this, for those that will be watching this. All right, let's take a look. All right, so in the on the screen here, you can see that they've done it like I did it, and I did it like they did it. Notice there's a 0 between negative 11 and 10, and negative 10. Well, what's the average of negative 11 and negative 10? Negative 10.5. That's as close as we can get. I mean, that's as close as we can get without having a graph. Did we have a graph on this problem? The one that we did? No, we didn't have a graph. So that's about as close as we can get. There's another 0, which is an actual 0. It's an integer. And here's another 0 between 20 and negative 35.5. And that's between 10 and 11, so that'd be approximately 10.5. All right? Now, if you look at the graph of this, you can see more clearly where it is. It's not exactly, it may not be exactly 10.5, but it's close enough for us. All right? So what did we just do? We were given a function and it said find the approximate real zeros of this function. Well, how did we do it? We made a table. We chose our own x values that kind of made sense. And then we plugged those x values into the calculator and got our y values. Then we were able to determine where the change of signs were, and we knew that between those x values is where we would have a 0. It's that simple, and that's all it's doing is asking you to approximate. Now, let's use the calculator to do one, and we can get much better readings on what our approximate values are. We're going to do a different function. All right, so let's take a look at a different function from our book. This is also on page 497, sorry. All right, on page 497, actually turn over to page 498. On page 498, it says approximate the real zeros of each function to the nearest tenth. So we're going to do number 19. F of x equals x to the 4th plus 2x cubed minus x squared minus 3. Okay, this time, however, we're going to use our calculator to do the approximations for us. Okay? So we first need to know how to plug this bad boy into the calculator. So let's go back to our camera. All right, when we plug these into the calculator, we've got to go to our function screen. The function screen is found by pressing y equals. Press y equals, and you should see a function in there. Clear the function, because we did this one earlier. Clear the function. All right, in your function, you need to type in number 19, which was x to the 4th. Now you say, well, where's x? The x button is below the mode, right here, right below the mode, right here. See it on the wall, on the poster? Press x, and then exponent 4. The next part of it is 2x cubed, so plus 2x to the 3rd minus x squared minus 3. So when you finish, you should have this in your calculator. It should look just like it does in the book. Jalen. Jalen. You're on video. Alright, so we've got it in our calculator. Now, we're going to graph it. To graph it, press graph. See the graph button right here to the far right? Press graph. And here it comes. You can see the graph. Now, I want you to notice that this graph has a scale where our x values go from -5 to 5. And our y values go from -10 to 10. That's how many little marks we've got. How did I do that? How did I make it have that scale? Go to the window button. You see in the window button, you can change the scales. I did from -5x to +5x on a scale of 1. You could do a scale of 2 or a scale of 0.5. Or you wouldn't want to do that probably, but look at my y scale. The y scale is -10 to 10 on a scale of 1. Alright? It's very simple. Now go back to graph. Okay, so you see your graph. How are we going to approximate these zeros of the function where it crosses the x-axis? Here's how you do it. Press trace. See the trace button next to the graph button. Now, it'll put a little cursor on the curve. All you do is use your right and left arrow keys to go to the graph. Alright, so now look at this first, the zero to the far left. Can I actually get exactly on the graph at this scale? No, I cannot. But am I very close to it? Look down at the bottom of the screen. -2.55. If I round that to the nearest tenth, what is it? -2.6. I want you to write that down somewhere. Write down -2.6. And keep that handy. Alright, now I want us to go over to this far right zero. Alright, and what is the closest that I can get to that zero? 1.06. Rounded to the nearest tenth is 1.1. So write that down. So we had -2.6 and 1.1. Alright, now that was number 19 on page 498. Guess what I'm going to do? I'm going to go to the back of the book where the answers are. Don't tell anybody. Don't tell anybody. Yeah. Page 498. Alright, number 19. Now, what I'm looking at on page 977, I'm looking at answers of -2.6 and 1.1. Is that what we have? Yeah. So guess what? The calculator will do approximations very easily. So we can do it by hand, or we can be more accurate and do it by the calculator. Alright? Now, I don't know how many of these I'm going to ask you to do. I'm going to ask you maybe a few. Okay? It's not going to be a ton of them. But can we use the calculator to do it? Just like that. It's that simple. Any questions about using the calculator to do these? Okay, now, while we're at it, let's do a few problems while we're in class. I'm not going to give you any homework to take home. We'll do you some classwork. All right, on page 498. Page 498, I want you to do 15, 16. Actually, I want you to do, 15, 16, and 17. 15 through 17 on page 498. And then on 2 of those, you can check your answers from back in the book. Okay, but don't go to the answers first. All right. Okay.
Coach, we really gonna run on that. We just gotta